All right, so just a reminder about the rest of this week while we're on distance learning. Today's Thursday, at least it should be when you're watching this. Just complete any missing Unit 4 work after you watch the video. I've got a couple of examples that'll help you with the Tuesday and Wednesday assignments. The first one will help with Tuesday's assignment. The second example will help with Wednesday's assignment. All right, so here's our first example where we're just going to graph the solutions to the system of inequalities listed there. Now, we'll notice that both of these inequalities are written in slope-intercept form. That's the form where it just kind of like starts with y and then the inequality symbol mx plus b. So I notice that I have a slope of 2 in that first inequality and a y-intercept at -3. So I'm going to use that to graph what I know. And let's see, let's do this one in red. So I have a slope of 2, which I'm going to use as 2 over 1. Remember, that's rise over run. And then my y-intercept, or the b in that formula, is -3. So we're going to start by plotting the y-intercept first, because that's the only thing that represents a point out of that information. And then we use that slope, the rise of 2 and run of 1, to plot more points. It'll help us build our line. Keeping in mind, when your slope is positive like this, your line should be going up and to the right. So that's exactly how we want to rise and run, by going up 2 and to the right 1. Will get us another point on our boundary line. Now at this point, we really could graph the line, but it'll be much nicer and it'll look better if we plot additional points by continuing that pattern for slope. Rise 2, run 1. Go all the way to the edge of the graph space until you can't go any further. Then check to see if you can go backwards. The opposite of what we just did would be if we go down 2 and back to the left 1. And it looks like I have enough space to do that one time. So I know where my line's going to be, but before we draw it, we have to remember that there are 2 different types of lines, and it's all based on that inequality symbol. Since this one has the little line underneath it, we want to draw a solid boundary line. So I'm going to put arrows on both ends. It's a solid line, not dashed. And I can draw my line to go through the points as best as possible. That's my boundary. From there, I want to determine which side of that boundary line contains all the solutions. In the inequality symbol, the less than part of the symbol tells me that I want to shade below the line. So I know that I want to shade anything that's below or underneath this line. But before I do that, I'm going to have to figure out the other part of the boundary. So I'm not just graphing a single inequality, I'm graphing the whole system. So for right now, I just make little marks to remind me that it's going to be somewhere over there on that lower right-hand side. Now let's do the same thing for our second inequality. We identify the slope, which is -1/3, the y-intercept, which is +2. So I'm going to do this one in blue. So -1/3 is my slope, y-intercept's +2. So on my graph, I start at +2. It's my y-intercept. And now I want to use my slope of -1/3. Keeping in mind, with a negative slope, my line must be going down and to the right. Positive slopes went up and to the right. So negative slopes, I want to go down 1 and then to the right 3. So I rise -1 and I run +3. I do that until I run out of space and can't do that anymore. Then I work backwards. Up 1 and to the left 3. Make sure everything lines up nicely. And before we draw the line, we double check to see what type of line. And that comes from the inequality symbol. Because our inequality symbol this time is a strict inequality, meaning it's not equal to, it just says greater than, but not equal to, we want to draw a dashed boundary line this time. So I've got arrows on both ends. I have the dash symbol selected. I'm going to try to draw a line that goes through those points as much as possible. There we go. Now for that dashed line, we had that inequality symbol that was greater than. And the greater than symbol tells us that we should be shading above the line. The solutions have to be above it. So we have 4 different regions to choose from. We need to shade the one area that was below the first line, but above the second line. And if we check with our arrows where that area is, it's going to be the area up here in the upper right-hand corner. Now I'm going to show the same thing, but use my highlighter to overlap. That gives us a better visual representation of why we choose that area. So I'm going to start in yellow for this first one, my solid boundary, my solid line boundary. We wanted to shade below that line because it was a less than symbol. And then for my second inequality, that was the dashed line. It said greater than was my symbol. I want to shade above that line because of the greater than part. So I'm looking for where do these two solution areas overlap. It's going to be this area in the upper right-hand corner. So my final product is going to look like it's only shaded in this upper right-hand corner. That's where all the solutions are for this system. All right, so that's graphing a system of inequalities when the inequalities are written in slope-intercept form, where y is by itself. Let's take a look at our second example. Now, this is like Wednesday's lesson, where we want to graph our inequalities that are written in standard form. And to do this, we want to actually find the intercepts for both inequalities. Find the x-intercept and the y-intercept. And if you recall from class, we can take our inequality, our statement here, and we're basically just going to do a little dividing. Color code here to make things stand out a little bit more. All right, so to find our x-intercept, we're basically canceling out the y term and solving what's there. 9x equals 18. Well, to do that, I would just divide. I'd take 18 divided by 9, which is 2. So I have an x-intercept of 2 for that first inequality. For the y-intercept, let's do the same thing. But this time, I would cancel out the x term and solve what's left. 6y equals 18. Well, I divide 18 by 6 to solve that. 18 divided by 6 is 3. So my y-intercept is positive 3. Now for my boundary line, I follow the same rules that we used in the first example. We're really looking to see what is that inequality symbol, and does that give us a solid or a dashed line? And because here we have a not equal to symbol, it's just less than, we want to draw a dashed line like we did on the last one. So dashed line, arrows on both ends, and this one might be a little bit harder to get this in place because I don't have as many points to aim for. Move this one over just a little. That's pretty good. Extend your line all the way across the graph space. Now, in terms of finding the area that should be shaded, we test a point. Okay, I always like to use 0, 0 and check to see if that's a solution. If it is, I'm going to think about this side being shaded because that's the side that has 0, 0. If the origin is not a solution, then that means I want to think about shading the opposite side of the line. So if we plug our zeros in for x and in for y and do a little math, we do 9 times 0 plus 6 times 0. Well, that whole thing just ends up being 0. So when we compare that to the other side, is 0 less than 18, we see that that is true. All right, so what that tells me is that the origin is on the solution side. So I want to just think about all of my solutions have to be kind of below that line on the left-hand side. All right, let's do the same thing for the second inequality, and then we'll be able to shade the solutions. 4x minus 6y is greater than or equal to negative 12. highlight to color code. We're using the highlighter here to just give us that visual for finding the intercepts. So for my x-intercept, I'm going to divide the negative 12 by the coefficient of x. So negative 12 divided by 4 is negative 3. My x-intercept is at negative 3. My y-intercept, when I take negative 12 and divide it by the coefficient of y, and two negatives divided will give you a positive answer, so that's going to give us positive 2 on the y-axis. So I have my two blue dots represent the intercepts of that second inequality. Before I draw my line and graph my line, I have to remember to check for the type of line. Based on that inequality symbol, this tells me that I should draw a solid line because my inequality is one of the equal to symbols. So I'm going to grab my straight line tool, arrows on both ends, and try to draw my line all the way across the graph to the other end extended, going through the points as much as possible and adjusting if we have to. So we have our straight or our solid line in place. The next thing we need to do is determine which side of that line contains the solutions. So again, let's check the origin. If the origin, or 0, 0, is a solution for that solid boundary line inequality, I'm going to shade the side that contains the origin, 0, 0. If it's not a solution, then I'm thinking about this other side of the boundary line having the solutions. So let's test it. I plug a 0 in for x and a 0 in for y. I do 4 times 0 minus 6 times 0. Well, that's just 0. And the rest of the inequality read that 0 is greater than or equal to negative 12. So we have to think about that. Is 0 greater than negative 12? Yeah, 0 is greater than any negative number. So this one is also true, meaning that the origin is a solution to the second inequality. So I will want to think about shading that big side of the solid boundary line. So I'm just going to make a little mark to remind me, shade below that line because the origin was a solution. So now let's use highlighter to help give us that visual for which of those 4 areas should actually be shaded for our answer. Well, my first inequality was the dashed line, and we said that we should be shading the lower left-hand side of the dashed line. Shade that in yellow. My solid line was the boundary of the second inequality, and we said we should shade the side that has 0, 0, so that's the side underneath that one. So it looks like the yellow and the blue will overlap in that area in the, I guess, center middle, or the bottom middle section, bottom left section of our graph space. That's the area that contains all of the solutions to the whole system. So I'm going to undo the highlighter, and I'm only going to highlight the area that contains the solutions. All of those ordered pairs, if we plug them in for x and y, would make both inequalities true at the same time. All right, so just a reminder that what I'd like you to do is complete any missing work from Unit 4, and I'll see you guys tomorrow. The Google Meet links are right there in Schoology. You'll also find them on your Google Calendar, or even if you check on Friday morning, you'll find the link in the Rapid Identity tile for Google Meet. See you later.